Hi everybody, Mrs. Danielson here, and today we're going to talk about graphing our complex numbers. We've talked about imaginary numbers and complex numbers before. We've just never had a way to graph them. They didn't really work on our normal rectangular plane. We needed something special to help us graph them, and that's what we're going to be working on today. So we're going to be graphing our complex numbers. Remember, complex numbers look like a plus bi. A plus bi. There's a real part plus an imaginary part. And it's the imaginary part that's made it hard for us to be able to graph them, right? On a normal XY coordinate grid just didn't really work. So today what we're going to do is we're going to bring in this complex plane here. That makes it possible for us to graph those complex numbers, right? So the x-axis is now going to become our real axis. That's where we're going to do the real part of our numbers. And the y-axis is going to become our imaginary axis. And they're actually going to work the same as when they were just x and y axes. So the real axis is going to have positive real numbers to the right, negative real numbers to the left, and the imaginary axis is going to have positive numbers going up and negative imaginary numbers going down. Okay, so in that way it still works exactly the same. Let's go ahead and just plot some numbers so you can see how it works. So let's say we have a complex number that is, let's start with negative 5i. So there's no real part, there's just an imaginary part. Then you would just go down the negative imaginary axis and you would be right here at negative 5i. Okay, let's try another one. Let's say we just have a real part and no imaginary part. Okay, in that case, you would be on the real axis at 2. Okay, now let's do somewhere it's like a combination of both real and imaginary, so a real complex number. Okay, so we'd like 2 minus I. Okay, then you would go over to 2 on the real axis and then down to negative I for the imaginary part, right? So that'd be 2 minus I. Okay, or let's try another one, negative 2 plus 5i. So negative 2 for the real part, positive 5i for the imaginary part means you go over to negative 2 and then up to 5i for the imaginary part. Okay, so that would be negative 2 plus 5i. And it's really that simple, right? We just are replacing the imaginary axis on the y-axis, and then it works the same way as a normal coordinate grid. Okay, now let's add a little something to that. So that's just plotting your numbers using the real and imaginary axis. Let's work on adding the addition of numbers in the complex plane. Okay, so we're going to be adding these numbers together. Okay, so to add complex numbers, you just add the real parts and you add the imaginary parts. It's as simple as that. So to add complex numbers, okay, you're just going to add the real parts and add the imaginary parts. Okay, so let's do an example that we're not using the graphing for, just adding 2 complex numbers. So let's take 2 numbers. Let's say we have 2 plus 3i and another one, which is 3 minus 2i, and we want to add those together. So what is z1 plus z2? Okay. All right. So we can just add those together by adding the real parts and adding the imaginary parts, right? So z1 plus z2 The real parts would be 2 plus 3. And then we would add together the imaginary parts, which would be 3i and negative 2i. So 2 plus 3 would be 5. And the imaginary parts combined would be a positive 3i and a negative 2i, so it would be plus 1i. Just adding together the real parts and adding together the imaginary parts like that. Okay, but what does that addition look like if we do it on the complex plane? Let's take a look at that. Okay, I have one down here just waiting for us. We're gonna grab that and bring it up. Okay, here we go. All right, it's not gonna quite fit on the page. We'll just fit it in. All right, let's rewrite what our numbers were now that it's on the other page. We had our first number, which was 2 plus 3i. And we had our second one, which was 3 minus 2i. Let's go ahead and write those two numbers on our complex plane. So one was at 2 plus 3i. So it's right about here. Z1. And our other one was at 3 minus 2i. So about right here, that's Z2. Okay. Now, if we connected both of those points to the origin, a nice straight line, let's see if I can do that. There we go. Do the same thing with Z2. Okay. Now, the sum of those two, we already figured out. Z1 plus Z2, right? We got on that last page, it was 5 plus I. So it was right about there. Okay. Now, the segments that connect Z1 and Z2 to the origin are the sides of a parallelogram, actually, right? Where the other sides are right here. Oh, I could probably draw that a little bit better. Let's try it again, right? All right, there we go. And there we go. All right, and we have ourselves a parallelogram. In this case, kind of looks like a square. Okay, but that is the parallelogram rule for addition. Okay, and it states that the segments connecting Z1 and Z2 to the origin are the sides of a parallelogram. With vertices, O for the origin, Z1, Z2, and Z1 plus Z2. I guess I didn't label that one there, but that's Z1 plus Z2. Okay, and this is going to come in handy further down the road. Okay, now I have another one I'm going to do that looks a little bit more like a parallelogram. This one looks kind of squarish, but it's still a parallelogram. Okay, so let's do one more. And here I grabbed another grid for us to use. Let's bring it up so we can use it. Okay, there we go. Put it down there. Okay, let's do another example that looks even more parallelogramish. Okay, so for this one, Z1 is going to be 3 minus 4i. And Z2 is going to be 4 minus 2i. We want to know what is Z1 plus Z2. Okay, and then we're going to plot those and we're going to see if we get that parallelogram rule, if we can see that. Okay, so first let's add them together. Okay, so Z1 plus Z2, right? You're going to add the real parts. Okay, and then you're going to add the imaginary parts. Okay, so let's simplify that up a little bit. And we get 3 plus 4, which is 7. And a 6i and a 2i, they're both negative. So that's negative 6i. So we could write it that way, 7 plus a negative 6i, or you could write it as 7 minus 6i. Either one is fine. Okay. All right, so that's our answer. Right, 7 minus 6i. A little bit better there. That's a little better. All right. So let's graph that answer and see if we can see that parallel rule for addition showing up. Okay, so Z1 was at 3 minus 4i. That puts us about right here. That's Z1. Z2 is at 4 minus 2i. Just about right there, I think. Okay, and then Z1 plus Z2, 7. Oh, it's just a tiny bit off. We're just going to estimate that there. Minus 6i. I think it's about right there, I think. Z1 plus Z2. Okay, so the rule says if I connect Z1 to the origin and Z2 to the origin, okay, and then I make my parallelogram using Z1 plus Z2, I get a parallelogram with those 4 points being the vertices. Can you see it? Yeah, not bad. That's a nice looking parallelogram. All right, excellent. So that is adding 2 complex numbers, and then it's also using our new complex plane. Okay, we can also subtract complex numbers. Let's do 1 or 2 of those. Okay. Let's see, make that look a little bit better. There we go. Okay, it's the same way with addition. You're just going to take, in this case, take the difference of the 2 real parts and then take the difference of the 2 imaginary parts and you'll have your answer. So let's go ahead and take 2 numbers and we'll just do it. Okay, let's say we have these 2, Z1 and Z2. Okay, and I'm going to take the difference of the 2 real parts and the difference of the 2 imaginary parts. I want Z1 minus Z2, right? So we're going to do 3 plus 6i minus negative 7 plus 2i. So first look at the real part, right? You'd have 3 minus negative 7, which is the same thing as 3 plus 7. So that's going to give me 10. Okay, now look at the imaginary parts, and we get 6i minus a positive 2i, which is 6i minus 2i, which gives me, right, let's see, 6. Oh, that should be a minus 2i right there, right? So 6i minus a negative 2i, which is 6i plus 2i. That's 8i. And there's your answer. Okay. Let's do one more. Okay, another example of subtracting 2 complex numbers. 3i and 9 minus I. And we're looking for the difference of the 2. And I want you to pause the video at this point and do it on your own. And then once you get an answer, you're going to turn the video back on and we'll see if we have the same answer. Okay, so pause the video. All right, you turn the video back on. I assume you have an answer. Let's see if we have the same thing. Okay, so we're gonna have the first one, 1, -1 minus 3i, and we're gonna subtract from that 9 minus I. Okay, so the real part is -1 minus n, right, which is gonna give you a -10. And for the imaginary part, you have -3i minus -i, which is a positive I. So -3i plus I is minus 2i. Is that what you got? I sure hope so. Okay. Okay, thank you for watching, everybody. That's our introduction to the complex plane. Everybody, have a great day.